Hi everyone. In this section we're going to be talking about how to graph quadratics using different forms of a quadratic equation, which we've already talked about several forms of a quadratic equation, one of them being standard form of a quadratic equation. So the standard form of a quadratic is y equals ax squared plus bx plus c. Okay, so we're going to learn how to graph quadratics by hand. In a little bit, you guys are going to complete an activity where you learn about different parts of the parabola and how to graph these things on a calculator. But right now, what we're going to talk about is how to do this by hand, which is really cool. So we need to go over some very important parts of a parabola. So some of these we've already gone over before. We have our x-intercepts, which is where the graph intersects with the x-axis or smacks the x-axis. Okay, the y-intercept is where the graph intersects with the y-axis. Okay, and the vertex is either the maximum or minimum point of your parabola. In this case, it's a minimum because the parabola is facing up. Now, a new part we need to go over about our parabola is called the axis of symmetry, which this is an imaginary line that's drawn in on the graph. That's why we have it dashed. Imaginary lines we usually draw in with graphs. So these are lines you can't see but are secretly there. Okay, so the axis of symmetry will be a vertical line that will divide your parabola in half. Hence the name axis of symmetry. It creates symmetry with your parabola. So if I were to reflect this half of your parabola over the line of symmetry, it would be identical on the other side. So this is called the axis of symmetry. So finding all these key parts will help us to graph a quadratic in standard form. So you guys will learn how to find the x-intercepts, the y-intercept, the vertex point, and the axis of symmetry from standard form. And when we put all of these parts together, they will form a beautiful parabola. That is the name of a quadratic graph. Okay, so again, you guys just did an activity where you found out the relationship between the standard form equation and how to get the axis of symmetry equation. So how we're going to get the axis of symmetry equation from standard form is to do x equals negative b, or the opposite of b, over 2a. We've already reviewed this before. When a is positive or greater than 0, remember it makes a happy face. So your parabola will face up and your parabola will be, or it will have a minimum point. When a is less than 0, it's a negative parabola, and negative parabolas make sad faces because they're negative. And the sad face will face downward, which means your parabola will have a maximum point. Okay, the C value, we're going to find out how to find your y-intercept, but we're going to talk about a shortcut which involves the C value, which I don't want to quite give it away. I mean, it kind of is giving it away right now, but that's okay. Okay, so example 1, again, we're going to start from standard form. We're going to find all of these lovely pieces, which ultimately, you guys, we're just going to be finding, oh, I went too far. Ultimately, still too far. We're going to be finding all of these key parts, which will help us to graph the parabola. So we will be identifying the A, B, and C, which will help us to find the axis of symmetry equation. Then we're going to find the y value of the axis, or of the vertex point, because you found out in the activity that the x value for the axis of symmetry is actually your x value in your vertex point. We'll be determining if the parabola will have a maximum or minimum by our a value. We will find the y-intercept and also the 0. So all of these nifty parts will go into play and help us to graph our parabolas, which this stuff is really fun, you guys. This is some of my favorite stuff to do in math. So let's get going on example 1. Let me pull it up. Okay, so, let me maximize this. Okay, so we're going to be finding all of these lovely parts of a parabola, and currently, of course, my screen is frozen. Crap. Okay, let's see if I can fix it. Come on, thing. Don't do this to me. Alright, guys, sorry, I'm going to have to fix it. Hold on. Oh, now it's working. Okay, oh no, I did something. Okay, I think it's working now. Okay, we're good to go. We're good. Sorry, you guys. Okay, so let's get going. So, I have my lovely equation in standard form, and doing all of this nice math work right here will help us to graph our parabola by hand, which is pretty exciting. Okay, well, let's get started. So the first step, we're going to identify the A, B, and C, which I know that you guys already know what these values are. Okay, so the A value is the number in front of the X squared. Now, currently, I don't have a number in front of my X squared, which means there's secretly a 1. And since there's a negative out in front, it means there's secretly a negative 1 out in front. Okay, the B value is the number in front of the X, which is 6. And the C value is the number without the X, which is negative 9. Okay, so using these values will help us to calculate different things about our parabola. So the first thing we're going to find is our axis of symmetry. And after we find the axis of symmetry, we will graph it. Okay, so don't forget the axis of symmetry is an imaginary vertical line that will show the halfway point of our parabola, or divide it in half. It will slice it in half. It will be quite violent. Okay, so how we find the axis of symmetry is by doing the opposite of B over 2a. Okay, so the opposite of B is positive 6, so the opposite of B will be negative 6 over 2 times our A value, which is negative 1. Okay, so this will end up being negative 6 over 2 times negative 1, which is negative 2, and negative 6 over negative 2 is 3. Okay, so my axis of symmetry equation is x equals 3. Okay, so that is where I'm going to be drawing my dashed line, which will divide my parabola in half. And I'm going to do it in purple. I feel like doing it in purple. Okay, so this is the vertical line that will hit the x-axis of 3, or smack that thing at 3. Okay, so we'll hit it at 3 right there. Okay, so it's a vertical line at 3. And I'm going to draw it as a dashed line because it's an invisible line that we can't see. And in math, whenever we have these invisible lines, we always do dashed lines. Okay, so here's my halfway point, or my axis of symmetry. Okay, so now we're going to find the y value of the vertex point. Now, you guys learned from that nifty activity that the axis of symmetry is actually going to be the x value, or the h value, of your vertex point. So my h value, which is the x value of the point, because it's the first value of the point, is going to be my axis of symmetry, which is a 3. Okay, so my 3, I'm going to rewrite right here. That's where that's coming from. All right, now how we find the y value, we are going to substitute in our axis of symmetry value in for x and solve for y. So I'm going to replace every single x with the 3, and that will give me the k value of my vertex point, which is essentially the y value because it's the second point. Okay, so we're going to have y equals, let's see here, we have a negative 1 out in front, so negative 1, I'm going to replace my x with a 3. So my x will transform into a 3, so it'll be 3 squared plus 6 times, which I'm going to do it in purple to keep it consistent, why not? Okay, 6 times x, which we know x is going to transform into a 3, and then minus 9. All right, let's solve this thing for y. Now, in this term, we have to be careful. You have to think about order of operations when you solve this term. Okay, in order of operations, do you multiply first or do you apply exponents first? Well, in order of operations, the exponent comes first. So we're going to square the 3 first, and then after that, we're going to multiply by a negative 1. Don't you dare do negative 1 times 3, which is negative 3, and then square that. That will be wrong, and that's when the demon cats will get you. So watch out. Okay, so we have y equals negative 1 times 3 squared, which is 9. All right, and I'm just going to keep simplifying. So 6 times 3 is 18, and I'm just going to throw the minus 9 on the end. All right, let's combine some of these. So I have y equals negative 1 times 9 is negative 9, and 18 minus 9 is positive 9. And guess what, you guys? Negative 9 plus 9 is 0. So the y value of my vertex point is 0. So that's where that's coming from. Okay, so I'm going to go ahead and plot my vertex point. Okay, I'm going to plot it in blue. Okay, so my vertex point is at the point 3, 0. Okay, so 3, 0. That is my vertex. Okay? All right, so now I need to know what the A value is to determine if my parabola will have a maximum or minimum, which will tell me if it's opening up or if it's opening down. I can't really do it with that hand. Okay, so the A value, I'm going to look back at my original equation. The A value is a -1. Okay, so my A value is a -1. Okay, and so since the A value is negative, so A is less than 0. Okay, and that means we have a sad face because negative people are sad. So that means we're going to have a maximum. So that's telling me I'm going to have a maximum. So I know my vertex point is the highest point on my parabola. Okay, the next step, to find the y-intercept. Now, if you guys notice, when we have points on the y-axis, those are things like 0, 1, 0, 2, 0, 3, 0, -5, 0, -7, 0, -10. If you notice, what is x every single time? Holy hot dog. X is always 0 on the y-axis. So to find the y value or the y-intercept, we're going to substitute in 0 for all of our x's and solve for y. Okay, so let's see here. We have y equals -1 times x, which x this time will transform into a 0. Okay, we're making all of our x's 0 right now. So we have -1 times 0 squared, and then plus 6 times x, which remember x is going to transform into a 0. So plus 6 times 0 minus 9. All right, so again, we have to do exponents first. So 0 squared, or 0 times 0 is 0, and 0 times -1 is 0, plus 6 times 0 is 0, and then I'm going to bring on down that 9. And 0 plus 0 minus 9 is -9. All right, so my y-intercept is where y equals -9, or at the point 0, -9. Those mean the same thing. Now, I'm going to teach you a shortcut, but you have to be careful. You can only use this shortcut when you start from standard form. No other form of a quadratic equation will this work. If you guys notice, we got -9 for our y-intercept. Which value in standard form is equal to -9? Do you guys see it? It's the c value. Okay, so in standard form, your y-intercept is always going to be the c value. So from here on out, I'm going to use the shortcut and just say, well, the y-intercept is c, which is -9. Okay, so I'm going to go ahead and plot my y-intercept point at -9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's my y-intercept. I'm going to abbreviate because I'm a mathematician and I'm lazy. Now, another helpful thing that you can use your axis of symmetry for is you can get more points on your graph, because if this is the halfway point, we can reflect points over that line and get more points on our parabola. And the more points that you guys have on your parabola, the more accurate your graph will be. Okay, so I see here that my y-intercept is 1, 2, 3 spaces away from my axis of symmetry. So if I reflect it over this line, it'll be 3 spaces to the right of that line. So I'm going to be in the same spot on my y. So I'm going to go down -9, and I'm going to count 3 to the right. So 1, 2, 3, bam. So I'm going to use my axis of symmetry to reflect my y-intercept over. So then I have more points on my graph, which is pretty cool. Okay, now the last step is to find the zeros, the roots, or the x-intercepts, which you guys are pros at doing that. There are several, oh, I just marked all over my paper. There are several ways you guys can do this. In this case, the square root property is not going to work because we have the linear term, which is a no-no if you're going to use the square root property. So in this problem, you can try to factor. Remember, factoring doesn't always work though. You can always use the quadratic formula or complete the square. So you guys can solve for the zeros in any of those ways. Okay, I'm personally going to choose factoring. Okay, I personally like factoring the best. It's a little faster, but sometimes it doesn't work. So I'm going to see if factoring works. And if it doesn't, then I'll have to try a different way to find the zeros. Okay, and I'm going to kind of divide this off right here because I didn't really save enough space to find my zeros. So I'm going to find my zeros up here. Okay, so remember when you find your zeros or roots or x-intercept, that's when we make y equal 0. So to find your x-intercepts, you make y equal to 0. To find your y-intercept, you make x equal to 0. So it's kind of like you make the other value 0 when you're finding an x or y-intercept. All right, so I'm going to start by making my y equal to 0. So I'm going to have 0, what's here? 0 equals negative 1x squared plus 6x, and then minus 9. Okay, so remember you guys, the very first thing we always look for before we factor anyway is by factoring out the GCF, which remember, your leading coefficient must be positive before you can start factoring, which currently it's a negative. So I need to factor out a negative 1 first using my GCF. And that will transform my negative 1 into a positive 1. Okay, so I'm going to start by factoring out that negative 1. So I'm going to divide every single term by a negative 1 and write what's left over in my parenthesis, which negative 1 divided by negative 1 will cancel and turn to 1. So I'm left with 1x squared, or just x squared. Then 6 divided by negative 1 is negative 6. And I have the x left over, so I'm going to bring that down. And then negative 9 divided by negative 1 is a positive 9. Okay, now from here, what I'm going to do, I'm going to look inside of my parenthesis, and I'm going to ask myself if I can keep factoring. Which if I have 3 terms in a quadratic, because my highest exponent is a 2, which factoring technique can I use? That is correct. It is slide and divide, or general factoring. All right, so I'm going to start by sliding and dividing. I'm going to find 2 numbers that will multiply to equal my A times my C, and then 2 numbers that will add to be B. Okay? I'm just going to kind of set this up real quickly. All right, we know it equals 0. I'm going to transfer my equals 0 over here, though. Okay? All right, so I'm going to slide A to C, which this time, since I don't have a number in front of my x now, it's secretly a positive 1. So I'm going to multiply positive 1 to 9, which positive 1 times 9 is 9. And then I want to add to be B, which is negative 6. Okay? Now don't forget, we slide and divide. So I'm going to divide by my A value, which in this case was a positive 1. Okay, so I need 2 numbers that multiply to be positive 9. Okay, so that means they're either both positive or both negative, and they have to add to be a negative 6. So, since I see they have to add to be a negative 6, both of these need to be negative. 2 positives will not add to be a negative. Okay, so do you guys know some numbers that will multiply to be 9 and add to be negative 6? Well, 1 and 9 won't work. 1 and 9, negative 1 minus 9 is negative 10, so that's not going to work. But what's the other thing that multiplies to be 9? Holy hot dog, that would be a 3. All right, so negative 3 times negative 3 is positive 9, and negative 3 minus 3 more is negative 6. Okay, so I'm going to bring these on down. Bring it on down. All right, I'm going to simplify each of my parentheses. Negative 3 over 1 is negative 3. So both of these are going to be x minus 3. Okay, and then the last step to figure out the zeros, I have something times something equals 0. So that means that at least one of these has to be 0. So remember, you can either set each of these equal to 0 and solve for x, or the shortcut I taught you, since the number in front of x is 1, we can simply flip the sign. So the opposite of -3 is +3. And each of them will be 3. So I have the same 0, but this is called a double root because my 0 repeated. So the 0 is located on the x-axis at 3, or you can write the point 3, 0. That means the same thing. Okay? So if you guys look here, our vertex point is already at the zeros because guess what? The vertex is on the x-axis. It's an x-intercept. So these zeros are the same thing as the vertex. Okay, and now that I have, so these are also the zeros if you want to include that. Or if you want to call them x-intercepts, whatever you prefer, they mean the same thing. All right, so now that we have all 3 of our points, I can now sketch in my lovely parabola. All right, so I know it's facing down. I know it has to hit all 3 of these points, which I'm usually not the best at drawing it. You guys are probably going to be a lot better than me, so I apologize in advance. All right, let's see. There we go. All right, it's going to keep going. Look at that, you guys. Doing all that work led up to graphing our beautiful parabola. And probably the most important step of this whole thing is to name your graph. Your graph deserves a name, you guys. So my graph's name is going to be Cheryl. I think that's a beautiful name. So I'm going to name my graph Cheryl. There you go. All right, example 2 is going to be the exact same. So let's get going.